The last session of the day today is entitled Public Perceptions, Priorities, and Solar System Exploration. My name is Heidi Hammel. I am a planetary scientist. I am pale, but I am not male, and I am not stale. This is the time for the women to take over the panels. I hope you notice that. So we are going to get into this here. Our first speaker today will be Linda Billings, who is a fellow at George Washington University School of Media and Public Affairs right here in Washington. She does communications research. She has her PhD in mass communication from Indiana University, and quite a diverse field of research, including science and risk communication, social studies of science, and the rhetoric of science in space. We've certainly been hearing some rhetoric today. She has a lot of experience in many different areas, including lots of editorial work. And today, she will be talking to us about a very interesting scientific urban myth about the presence of materials that have come back from the moon, or not. So, Linda.
Slides. Slides to be queued up. In the meantime, for those of you watching on the web, I want to say that this is a story that depends on a lot of details. And I'm going to try to go back to there we go. Yes, thank you. Thank you, Jonathan. And the details are not going to be in my talk because we don't have a lot of time, but they are in my paper, and I will email the paper to anybody who wants to read it. BillingsLinda1@gmail.com, BillingsLinda1@gmail.com, and that goes for everybody in the audience as well. So, my story is about a survivor, or not, the story of S. mitis on the moon. S. mitis is Streptococcus mitis, a bacteria that probably all of us have living in our mouths right now, and I'll get to that in a minute. The story of how NASA technicians found a viable Streptococcus mitis bacteria inside equipment retrieved from the moon and returned to Earth by astronauts has been replicated widely and reported as fact for decades. But it appears to be false, and I'm going to try to explain my case today. More than 30 years after the story was first told in 1970, it may be difficult to prove it definitively true or definitively false. However, the evidence now points to false, in large part thanks to the unearthing of old visual records. I'll make the case that the claim that S. mitis traveled from Earth to the moon, returned to Earth, and came back to life in a lab does not qualify as scientific truth. This story has relevance to astrobiology, planetary protection, planetary exploration, and of course, the history and sociology of science. As most people know all too well, bacteria are hardy little buggers. The existence of extremophilic microbial life, an exotic concept just a few decades ago, is now common knowledge. We know that some microbes can form spores, dormant non-reproductive structures that enable them to survive harsh conditions. Thanks in part to 50 years of exobiology and astrobiology research, we know that microbes can thrive in virtually every sort of Earth environment known to science, and that some can survive radical changes in environmental conditions for years, centuries, or some claim even longer. Meanwhile, planetary exploration has revealed that Mars and the Jovian moons Europa, Ganymede, and Callisto may have liquid water environments that could support life as we know it. Maybe Enceladus, too. We've heard about this from previous speakers. For missions to these targets, planetary protection, the practice of protecting solar system bodies from contamination by Earth life and protecting Earth from possible life forms that may be returned from other solar system bodies, has become a complicated enterprise. And John Sarkisian asked a question at the end of the last session that related to planetary protection, and NASA's current planetary protection officer, Cassie Conley, is here to answer any questions about that. So let's get on with our story. Here are some, and dare I say it, facts about S. mitis. This bacterium is part of the oriflora of mammals. And there it is. I'll introduce you to it. It does not form spores. It lives optimally at temperatures between 30 and 35 degrees Celsius, which is approximately 85 to 95 degrees Fahrenheit, and it's commonly found in the human mouth. So think about this. Could S. Mitis travel from Earth to the moon, survive more than 2 years of exposure there, only to revive once brought back to Earth? And why were scientists and engineers even thinking about such possibilities in the 60s and 70s? Even before NASA came to be, the international science community was discussing the possibility of ET life and steps that might be taken to prevent forward and back contamination. In the early days of Apollo, NASA planned for the quarantine of astronauts and material samples returned from the moon. A lunar receiving laboratory was built at the Manned Space Center in Houston, now Johnson Space Center, to contain and analyze lunar samples. I'm going to give you a little hint of the rest of the talk to come. In April 1967, NASA launched Surveyor 3 to the moon. It made a soft landing, operated for 14 days, then shut down, mission accomplished. 2 years and 7 months later, NASA launched Apollo 12 to the moon. On November 19, 1969, Pete Conrad and Alan Bean landed their lunar module about 163 meters away from where Surveyor 3 sat in the ocean of storms. On November 20, the astronauts retrieved several pieces of equipment from Surveyor, including its camera. They stashed the camera in a sample pack, zipped it shut, brought it back to the lunar module, stowed it on board, and took it home to Earth. The crew returned to Earth on November 24. Photos that splashed down show they are not wearing their protective biological isolation garments. Once the astronauts were moved from their capsule to an aircraft carrier, they donned their protective garments and entered an isolation unit aboard the carrier. The pack containing the Surveyor camera was retrieved from the capsule and delivered to the lunar receiving lab, where it was stored at room temperature in a Teflon bag. On January 8, 1970, Lunar Receiving Lab personnel began examining the camera. Microbial analysis came first as soon as the camera was opened. Working in a clean room environment, they performed standard microbial assays, and after 4 days of incubation, one sample apparently produced visible microbial growth. The apparently microbe-laden sample had been taken from foam embedded inside the camera. The isolate was identified with confirmation from the U.S. Public Health Service as Streptococcus mitis. In March 1971, at the second Lunar Science Conference in Houston, this is where this slide comes in, the results of this analysis were reported and later published in conference proceedings. F.J. Mitchell, a U.S. Air Force major assigned to the Preventive Medicine Division of NASA's Manned Space Center, and R.H. Ellis, a contractor working at the center, claimed that the S. mitis that had been cultured in the lab had traveled to the moon on Surveyor 3, survived on the lunar surface for 2.5 years, and once returned to Earth, revived and reproduced. This is a quote from their paper. Decontamination measures taken before the Surveyor launch did not eliminate the possibility that the spacecraft carried organisms to the moon. They described the conduct of the Surveyor 3 camera analysis in excruciating detail. Take my word for it, and I have a lot of those details in my paper. Another quote from their paper. The protocol established for the aerobic and anaerobic analyses contained a system of redundancy and cross-checks designed to identify suspected lab contamination. Only one sampled surface, a 1 cubic millimeter piece of foam inside the camera, produced visible microbial growth. Extreme precautions were taken at all times, they said in their paper, during the analysis to prevent any handling errors which might have caused contamination. The available data indicates their conclusion that S. mitis was isolated from the foam sample and suggests that the bacterium was deposited on the Surveyor 3 TV camera before spacecraft launch. At the very same meeting, M.D. Nittle, M.S. Favero, and R.H. Green presented a paper in which they reported on the results of their microbial sampling of returned Surveyor 3 electrical cabling. Nittle and Green were with the Jet Propulsion Laboratory, and Favero was with the U.S. Public Health Department. Their findings raised some questions about Mitchell and Ellis's report. Now, keep in mind, these two papers were both presented at the same conference, and all these guys knew each other. Nittle, Favero, and Green chose to examine a piece of electrical wire bundling running from the Surveyor camera to another part of the spacecraft because earlier studies had shown that a high level of microbial contamination was associated with wiring bundles. If during the actual sampling of the wires, they observed, and I'm quoting here, a contaminant were accidentally introduced, it would be impossible to separate it from a lunar survivor. Thus, it was necessary, they said, to perform several simulated assays with a piece of sterile wiring bundle before the lunar sample was assayed, which they did. Prior to opening the sealed container containing the Surveyor 3 cable and other parts, technicians discovered that it had leaked. There was concern whether airborne bacterial contamination of the exterior wraps would penetrate to the interior of the bundle. Their work in the lab showed that if airborne bacteria did pass into the container through the leak, the wiring bundle wraps would protect the wires beneath it from contamination. Their results showed, quote, that no viable microorganisms were recovered from that portion of Surveyor 3 cable that was sampled. The implication was that if no viable microbes were found on these protected wiring samples, then it would not be likely that any viable microbes would be found elsewhere on the camera. NASA published verbatim the findings of both Mitchell and Ellis and Knittel et al. As reported at the 1970 conference in a 1972 report. Here's a couple pictures of the camera and another picture. And thanks to John Rummel, who's now in the back of the room, who got me started on this investigation, and then he'll come into the story pretty soon. In 1974, the prestigious peer-reviewed journal Annual Review of Microbiology published a paper by Gerald Taylor of Johnson Space Center's Life Sciences Directorate, which he was formerly with the Preventive Medicine Division there, that reported on advances in space microbiology. In this paper, Taylor cited the Lunar Science Conference papers by Mitchell and Ellis and by Knittel et al. In his text, however, Taylor described only the findings of Mitchell and Ellis as follows, quote, components of the Surveyor 3 spacecraft, which had resided on the moon for 2.5 years, were returned during the Apollo 12 mission and analyzed for the presence of viable microorganisms, except for the presence of S. mitis, which was considered by the investigators to have been embedded within the camera body before it left the Earth. No viable microbes were recovered from any of the tested components, end quote. Over the next 3 decades, according to Science Citation Index, Taylor's paper was cited in 31 peer-reviewed journal papers in publications ranging from Icarus and Infection and Immunity to Microbiology and Molecular Biology Reviews, Microbiological Research, and Trends in Biotechnology. Meanwhile, in places ranging from NASA fact sheets, Wikipedia entries, and websites ranging from credible to dubious, the account of how S. mitis survived for 27 months on the moon and came back to life on Earth were widely reported as fact. After 30 years, somebody decided to look into the story. During his second stint as NASA's Planetary Protection Officer from 1998 to 2006, John Rummel, a microbial ecologist by training, decided to investigate the survivor claim. He talked with people knowledgeable about the Surveyor camera analysis who had indicated that clean room procedures for the analysis were less than stringent. I began doing research for planetary protection in 2002. In a 2002 memo responding to a query from me about the story of S. mitis as a lunar survivor, which I'd stumbled across on the web and doing some routine research, Rummel said the claim is almost certainly incorrect. There was no peer-reviewed paper with that result at the time, nor has there ever been. Rummel told me that in 1998 he had gotten in touch with JPL Surveyor project scientist Leonard Jaffe about the survivor claim, and that Jaffe had told him there was a film of the procedure to sample the camera, and that the samplers had broken sterile protocol inadvertently by placing their sampling tool outside the sterile hood. Jaffe passed along to Rummel a message he had received from his Surveyor project colleague Richard Green, remember R.H. Green, of the Knittel, Favero, and Green paper about the LRL analysis of the Surveyor 3 camera. Green had told Jaffe, quote, "You were correct. The sampling of the camera was suspect. I took movie film of the entire procedure and it shows up on it as well. I believe I still have the film somewhere in storage. If it would be helpful, I could try and find it." That's a long story too. At an astrobiology conference in 2004, Rummel discussed Mitchell and Ellis's S. mitis survivor claim, and he asserted that the growth they had reported was the product of lab contamination, and he made a good case. A 2004 paper on biological contamination studies of lunar landing sites, co-authored by Rummel and published in the International Journal of Astrobiology, also challenged the claim in a similar fashion. In 2006, I began exploring the story of S. Mitis on the moon in earnest, searching the web for other accounts. On a NASA Goddard webpage, I found a following Science Question of the Week, provided by planetary scientist David Williams of NASA's National Space Science Data Center. The question, can anything from Earth live on the moon? The answer, yes. Scientists, the S. Mitis claim was reported here as fact, and quote from this webpage, scientists concluded that the S. Mitis was inside the camera originally and had managed to survive on the moon. At the same time, I found a much more detailed account of the survivor story on a Marshall Space Flight Center website, Science at NASA, dated 1998 and headlined, Earth Microbes on the Moon, 3 decades after Apollo 12, a remarkable colony of lunar survivors revisited. This account reports on, quote, an inadvertent stowaway, Streptococcus mitis, the only known survivor of unprotected space travel. How this remarkable feat of survival was accomplished only by strep bacteria remains speculative, but the significance of a living organism surviving for nearly 3 years in the harsh lunar environment may only now be placed in perspective after 3 decades of the biological revolution in understanding life in its favored conditions. Talk about rhetoric. Another official NASA record found online, the Apollo 12 Lunar Surface Journal, Surveyor Crater and Surveyor 3, includes a transcript of astronauts Conrad and Bean's conversation while they were on the lunar surface, plus post-flight commentary from them and others, in which they address the story of S. Mitis on the moon. In post-flight comments, Conrad said, quote, the thing that had the bacteria in it was the television camera, the styrofoam in between the inner and outer shells. There's a report on that. I always thought the most significant thing that we ever found on the whole goddamn moon was that little bacteria who came back and lived and nobody ever said squat about it. Anyone who knows Pete Conrad would recognize that quote. And that quote was widely replicated, I think in large part because of its color. In his post-flight comments, journal contributor Ken Glover noted, quote, there is a distinct possibility that the microbes found in the Surveyor TV camera got there as a result of post-flight contamination. As of 2004, it seems generally accepted that the history of this particular microbe found in the Surveyor 3 parts will never be resolved. I also found, this is kind of disturbing, a classroom teacher sheet for grades 9 through 12 called All About Microbes, developed for a NASA-sponsored project, which is now defunct, called NASA Explores. And it repeated this survivor story as fact, citing the Marshall website as its source of information. There were many, many other sources. And beyond the universe of nasa.gov, I found further accounts of the fact that S. Mitis was a survivor at reference.com, at Wikipedia, on a space.com reader forum, many, many other places. In 2006, I began contacting people at Johnson Space Center who might know something about the Surveyor camera analysis. Rummel told me Judy Alton, a curator with the JSC Astromaterials office, reportedly had a list of film and photographic records of the analysis, so I first contacted her. She found her handwritten list, provided it to us. Her colleague, Carlton Allen, referred us to John Lindsay with the Lunar and Planetary Institute's Center for Advanced Space Studies for help with our investigation. Lindsay advised that he was, quote, part of the preliminary examination team on Apollo 12, so have some feel for the way things went and would enjoy working on the data once again. I put my research on hold in late 2006 when Rummel stepped down as Planetary Protection Officer to take over the NASA astrobiology program. In 2008, Rummel left NASA and John Lindsay passed away, unrelated events. Nonetheless, Rummel still seemed determined to prove, if possible, that S. Mitis survivor was actually S. Mitis lab contamination. Ultimately, Rummel, Alston, and Don Morrison completed an investigation into the matter, and Rummel reported their results at a workshop in 2011. Rummel said that according to NASA records, the Surveyor 3 camera reached a maximum temperature of around 70 degrees Celsius on the moon. NASA records also showed that S. Mitis, quote, was isolated from the Apollo 12 crew in routine microbial testing. The team's investigation verified that no viable microbes were isolated from the Surveyor 3 cables or foam or from any Apollo surface samples, returned to Earth, and that no viable microbes were isolated from 10 of 11 sampling locations, 32 of 33 samples within the camera body. What clinched the trio's investigation, however, was that in 2010 they found the 16-millimeter film records of the 1970 Surveyor camera analysis, quote, in John's words, languishing in Maryland. All 3 researchers viewed and analyzed the film, and again, in John Rummel's words, it wasn't pretty. The film showed lab technicians working in short sleeves with only their mouths and noses covered by masks. At some points, they were working with bare hands. As Rummel observed, after all of that, how can you be sure where your microbes came from? More specifically, Morrison pinpointed an anomaly in camera foam sampling, which I've detailed in my paper. As to general protocol, Judy Alton noted, I will add that the participants were wearing short-sleeve scrubs, thus arms were exposed. Also that the scrub shirt tails were higher than the flow bench level and would act as a bellows for particulates from inside the shirt. On May 2, 2011, Space.com reported on Rummel et al.'s findings, describing the story of S. Mitis survivor as a long-lived bit of Apollo moon landing folklore that now appears to be a dead-end affair. Ooh, I missed some slides. Now here's a lovely picture. It's a little blurry because, of course, this is still imagery taken from 16 millimeter film, but you can see, get a good idea of what we're talking about here. The contestation, or shall we say refutation, of Mitchell and Ellis's claim has had some effect on the public record so far. While in 2006 I found numerous websites replicating the story of S. Mitis survivor, in 2012 I found only a few that were sticking with the story. In 2006 I had contacted David Williams at Goddard to advise that the claim he reported as fact was contested. In 2012 I looked for this page and it no longer exists. In 2012 at reference.com's online entry for Surveyor 3, at the very same URL that I checked in 2006, I found a completely different story about S. Mitis on the moon. And now this story reported that the claim of S. Mitis surviving on the moon and coming back to life on Earth has been cited as providing credence to the idea of interplanetary panspermia. However, NASA officials now no longer support this claim. Now, I believe even today, because I just checked this about a week ago, NASA Marshall's Science at NASA entry of 1998 has not been revised since it was posted there. Thus, in 2012, at least one NASA.gov webpage continues to report without question or qualification that S. Mitis did indeed survive for 2.5 years on the moon, come back to Earth, and come back to life. So it remains to be seen. We'll have to wait a few more years to see how long it will take to correct the public record. It's still with us. On the September 14 edition, just last month, of National Public Radio's Science Friday show, Ira Flato asked Cassie Conley, NASA's current planetary protection officer, about the bioassays of the Surveyor camera parts. And Cassie said, quote, "It turns out that the way they were taking those samples was about the same level of sterility as you do in surgery. So they had short-sleeved scrubs, they didn't really have good masks, so the samples that were contaminated were taken at the very end of this whole sampling process, and just after somebody breathed right on that location on the camera. So it probably was contamination after the camera was brought back." And there's another picture, just to show up close and personal. To wrap up, this story shows how a claim became a widely accepted fact without passing the conventional test of peer review, how initial counterclaims that challenged the status of the first claim as fact failed to register, how a later and perhaps more vigorous counterclaim ultimately led to a solid case against the first claim, and how consequently the first claim is losing its status as fact, I think. Rummel et al. Are interested in this story as a case that illustrates the importance of stringent compliance with planetary protection policy and procedures. And as we've heard from other speakers, in recent years, microbiology research has revealed the extent to which humans are teeming with microbial life, and the prospect of sending humans to extraterrestrial environments that might be habitable for Earth life greatly complicates the task of compliance with planetary protection requirements. NASA cleanroom practices have evolved considerably since the days of the Surveyor analysis, where cleanroom technicians wore short sleeves, to the present-day planetary protection requirement of bunny suits. There you go. I think this was from Genesis, John, is that right? The Genesis crew? Today, the scientific consensus is that it is not likely that terrestrial microbes could survive and thrive on the moon, and this consensus is reflected in planetary protection policy for missions to the moon, which designates those missions, Category 2, forays to a body of significant interest relative to the process of chemical evolution and the origin of life, but where there is only remote chance that contamination carried by a spacecraft could compromise future investigations. For Category 2 missions, forward contamination is not a concern. However, there is a concern that in extraterrestrial environments where liquid water might exist, and we've discussed many of them today, it could be possible for terrestrial microbes to thrive and replicate. And then forward contamination for missions to those targets is a serious concern, and planetary protection requirements are strict. So for planetary protection, this case illustrates, among other things, that microbes are everywhere, at least on Earth. Clean room procedures for microbial assays can't be too careful, and meticulous and complete records of such procedures must be made and preserved. For astrobiology, this case illustrates how difficult it will be to verify any claims of the detection of extraterrestrial life, something else we've been talking about today. Consider the Mars Science Laboratory, NASA's first astrobiology mission to Mars since Viking, now roving around Gale Crater, seeking evidence of habitability. Questions will continue to arise from the press and the public and the science community about the possibility of finding life on Mars or in other extraterrestrial environments. And how will we ever know for sure? For the history and sociology of science, this case shows how a claim that was never subjected to formal peer review became and remained a fact for decades before it was seriously challenged, and how it took visual evidence to finally make the case that multiple sources had made verbally. It shows how the paper trails that we researchers like to excavate for information are now intermingled with digital documentation that can be altered at any time without leaving any detectable evidence of an alteration. And it shows something that historians already know, that the record is never complete. Thank you.
Thank you. Are there questions for Linda?
Has
I know of him.
Yeah, I bet. And he showed me innumerable extremophiles that he has collected all around, and I wondered what his comments were on this.
I did not speak to him for this particular paper because his name did not show up. Oh, yeah, this pillar is getting in the way. I did not speak to him doing research for this particular paper because his name did not show up in any of these records.
He just retired from NASA, but
Yes.
he's still active, so you
Yes.
might want to do that.
Yes, there are lots and lots of people. I'm sure historians in the audience realize how much more I can do to fill out this story. This is just scratching the surface. I did not sit down and do a formal interview with anybody. I mean, I had some
I see.
conversations on the phone and
Well,
email
I bet he'd
correspondence.
love to talk to you. Okay, thank you.
Yeah, I will point out that it is possible for Streptococcus mitis to survive on the surface of the moon for 2.5 years if an astronaut is willing to stay on the surface of the moon for 2.5 years.
That's right.
Linda, your talk is very instructive indeed, and this is showing, well, how easily the different microbes adapt to the hostile environment. In this regard, I just would like to ask you, you know, we try to sterilize many Martian missions which we send, okay? But it's impossible to sterilize for reliably, completely. And some of them crashed when just landing on Mars. So the microbes possibly easily adapted to the natural environment on Mars, and even in the dynamical, very dynamical conditions in the Martian atmosphere, just easily proliferated over the Martian, the whole globe. So the question is whether we need to take care about sterilization for the future mission, what we are going to find out. Some kind of the mutations or just completely original terrestrial life forms. What do you think about that?
It's a serious challenge in the search for evidence of life elsewhere to know whether it's life we've never seen before or life that used to be like us, that, as you mentioned, might have evolved, changed, mutated. This is why the more we learn about planetary environments, potential habitability, and the more we learn about life, as David Grinspoon and others have discussed today, and how weird life really is. I mean, it's just amazing to me. It's mind-blowing to me. I'm not a biologist, obviously. The more difficult it will be for us to determine how to make sure that when we send that melter, who showed the slide of the nuclear, oh, that was last night at National Geographic, the melt probe, yeah, through the icy surface of Europa, that if we find anything there, it's not something that we brought with us. It's an extremely difficult challenge to meet. I see Vicki Hipkin, who's the Queen of Planetary Protection for the Canadian Space Agency, she's biting her lip, so it's a very, very hard job to do, but people are working at it.
Thank you. Let's thank our speaker again. My only comment about that, Linda, is that, somehow your work has been able to get this out of the web, and why can't they get rid of the story about the Mars being, the size of the full moon out, which comes around every August like clockwork? If you could work on that one next, I'd really appreciate it. Our next talk by William Macaulay, Instant Science, Space Probes, Planetary Exploration, and Televisuality, unfortunately had to be withdrawn. There were visa troubles for William Macaulay, and he can't be here. But his paper is quite interesting, and if you are interested in the use of visual imagery in space, the history of how visual imagery came to be such a big part of this space program, I suggest that you do track that paper down because it is a very interesting read. And our next topic is one that's near and dear to my heart because I happen to be in charge of the Hubble Space Telescope in 1994 when a comet, fragmented comet, Shoemaker-Levy 9, crashed into Jupiter, creating massive explosions on the planet, which was headline news for a full week. And how many of you saw that? I'm just curious. Yeah, a lot of you did. And that comes into the next story, which is entitled Killer Asteroids, Popular Depictions and Public Policy Influence by Laura Delgado López. Thank you, Laura.
Hello, everyone. I'm really happy to be here. And before I begin, I would just like to acknowledge that this paper came as a collaboration between myself and Dwayne Day from the NRC, whom you've heard earlier this morning. And so now let's just move right on to it. Killer asteroids. We know the story so well. Basically, we find out, usually by pure chance, that a monstrous asteroid is heading, hurling toward the planet and is threatening civilization. And, do we have time to do anything? Can we do anything about it? And so the story goes, and Bruce Willis, makes an appearance or something. But what we may not know is that this narrative is actually, goes back much further than we may believe. And so when we look at all of these examples, some of which I will mention today, we have to ask ourselves, what is behind this narrative? Was it prompted by real events? Can it tell us anything about real policy impacts or public opinion about it? And so to begin with, I'll tell you a little bit about the long and explosive history. And in the paper, which you may have an opportunity to see, there's a list at the end of a bunch of examples that we were able to find, some in other languages, as you see here, but just to show that this has been around a long time. The earliest example we found was a French novel published in 1890 titled La Fin du Monde, and it was republished again in the 30s and made into a movie in the 90s. And it was, again, one of the very earliest examples. And also at the time, we see the 40s, the 50s, also some other movies and books exploring the issue. In nonfiction, we see some work looking at asteroids, comets, and other planetary bodies, as a threat of a potential impact and what that meant. And so those early events, many of them probably came as a result of an early impact event in the 20th century, the 1908 Tunguska impact in Siberia. There are literally hundreds of works, both fiction and nonfiction, exploring exactly what happened there. And even as far back as, as recently as 2010, in the National Research Council report on asteroids and near-Earth objects, more recent research of what it is that happened that day was actually come to bear. Other important events that kind of help drive these narratives include the 1980 Alvarez hypothesis that for the first time linked the cataclysmic events that led to the extinction of the dinosaurs with an asteroid impact, and as Heidi mentioned, the 1994 Shoemaker-Levy 9 impact that again captured the attention of the world. And so as a result, particularly in the 90s, we see so many of these examples, over 25 in our survey alone. Also, during that time, planetary research had a role to play because the research that from several of the spacecraft that we had sent out were just confirming the role that impacts have had in transforming not just the phase but also the composition of other planets. And also that it became clear that our own planet had had impacts before and that those things were not just a thing of the past, that they could continue happening. They continued. These examples continued. I think events such as the debate over the non-negligible possibility of impact of asteroids such as Apophis or AG5 helped feed the sustaining narrative. There's also the misinterpretation of the Mayan prophecy that the world was going to end in 2012. That prompted more examples even this year in 2012. And so this survey and some of the examples that I've selected here are not exhaustive. I'm sure that if we keep looking, we will find more examples in maybe in other languages, in other countries. But just to show that this was not born with Armageddon and Deep Impact, which are the examples that very easily come to mind. But in fact, it's a narrative that has been very present throughout history and that was just strengthened by these events that captured the attention of the world. And so science fiction studies research will suggest to us that if we see a sustaining narrative, it should tell us something about real, deep-rooted perceptions in the public. And so if we look at all of these examples, we have to ask ourselves, well, are people really concerned about asteroid impacts? And the fact is they're not. At least what little research exists on the subject that has asked this very question. The first one, then maybe the first one of its kind, in 1993, Slovak and Peterson made a survey of 200 grad students, and they asked them to rank their risks in terms of concern. And impact risks ranked 24, and 14 out of 24, and were described as distant in time and non-immediate. And that result continued even in a survey that was performed by the Pew Research Center in 1999 and again in 2012 with almost identical results. The majority of the people surveyed described it as something that will probably not happen or will definitely not happen. And so, you know, we have to ask ourselves, why is that contradiction there? You know, why does that narrative keep occurring if it finds an indifferent public? And so for that, I think that we have to look at what kind of threat we're talking about. And first, we have to consider the uniqueness of the threat. If we look again at Paul Slovak's research on risk assessment, and they've developed a matrix where there's a couple of variables, including dread risk and unknown risk, that help rank risk assessments of the public towards specific issues. And we see that asteroid impacts would be described very highly by all of these characteristics, you know, uncontrollable, indiscriminate, catastrophic consequences, unknown to science. And that is how it is continually presented in the dominant narrative. It is captured as very risky and catastrophic. And as Slovak accurately describes, it has a unique combination of very low probability and very great consequence. In addition, the threat is also the more compelling because it is always presented as urgent. Even though we've been surveying asteroids for many decades, it always is just hiding behind the moon, or, you know, we can't see it. We only find out about it months or weeks or hours before it's supposed to impact the planet. Another element that's interesting is the tools that we use to tell that story, the tools of the trade. And so I think that this thread is particularly visually appealing. And with the advancements in visual arts and in special effects and CGI, what was in the 90s something that was very surprising, that we were very impressed as an audience that movie makers could do, became an expectation in the 2000s and afterwards. And so at this point, with relatively little cost, you can make pretty impressive imagery of the asteroid, the track and the moment of impact. And interestingly, you can keep going with that, because what happens after the impact happens? I think the asteroid threat presents a lot of opportunities for developers, particularly in film. to showcase advanced special effects that are not presented by other natural disasters such as earthquakes or hurricanes. And that's just worth a mention, you know, even in nonfiction works like documentaries like this one, titled Mega Disasters, asteroids are not the only thing that's discussed in that documentary, but they still made the cover. And so even in books, you have that. Maybe the asteroid impact happens in 5 pages, but you know, it's compelling enough that you will put it on the cover. And then the third element is, I think the reason why we're here today is the draw of space. The fact that the threat comes from space is very powerful. As McCurdy notes in his book, Space and the American Imagination, he talks about how space became entrenched in the American imagination, particularly after the Second World War. And so the idea that both threats and salvation would come from space was very compelling. And I think that has continued since then. I think you know, all of these elements together make for a very compelling, if unbelievable, thread. And so again, we see, you know, taking this slide and the previous slide together, we see its narrative that has continued, but all of these elements together, and particularly the tools of the trade, and the opportunity to make this narrative even more entertaining, even more amazing visually, just has this feedback loop continuing. And so, you know, there's almost no end. We will probably continue seeing even more examples about it. So we have that explained. We kind of understand now why we keep seeing it, but we still understand why people are not concerned about it when they think about the issue. And so for that, I think we have to look at how the story is represented, it's depicted, and you know, why is it not believable, and why is this giggle factor that the scientists would usually bemoan still alive? Well, you know, Houston, we have a problem. Cliches like that are particularly common in this kind of movie. With few exceptions, asteroid impact narratives make for decidedly unsuccessful movies, often only made watchable by the special effects used to image the asteroid and its path of destruction. There's narrative gaps, there are incorrect scientific and technological assumptions, predictable storylines, you keep going. And so these are some of these. One of them is, for example, incorrect science and technology, and I'm sure when you're in the audience as well, you start naming all of these, using the space shuttle to go to the asteroid and, you know, deploy the nuclear weapons. Another one that's interesting is this inflatedness role. It's interesting to me that in the real world, when we talk about the possibility of an asteroid impact and what do we do, there's all of these discussions about, you know, is it DOD, is it Department of Energy, is it NASA, is it all of it together? What happens with other countries? You know, do we want to cooperate with them if we want to solve this issue? None of that is in the main narrative. You know, NASA is automatically the source of the solutions, and they have this amazing budget that they can just take care of it. So, you know, it's fiction, but so a third element that, again, is also very interesting is this focus on science's limitations. You know, again, despite the fact that we've been surveying asteroids for decades, the asteroid is always a surprise. In Deep Impact, for example, the asteroid is found out by a 12-year-old with a not impressive telescope, not by a ground observatory, not by an academic institution, not by NASA, it's by a kid with a telescope. So, and then you see that also as well with the kind of fumbling with what do we do about it? Do we even know what's going on? And then finally, and I think this is a very important point too, is that asteroids are not the focal point of the story. They are the cover to discuss a lot of other issues, namely American values, the true nature of things. You know, when crisis comes, you see the true nature of people, that kind of thing. And so I think as a result, there is no requirement from either the movie makers or from us, the audience, to have an accurate depiction of asteroids, because the movies are not about that. And so when you think of, again, Armageddon, you think about that scene that has been recreated in countless movies. You don't think about the asteroid as the main character in that movie. And so what comes to mind for us in the audience is not a film about a threat that should concern us, but one where individual characters and their successes and failures and a lively scene or two of destruction are the focal point. Again, believable enough to keep us entertained, but not to wake us up at night. Now, in contrast to that, we have our scientific understanding of the threat. And while the public is entertained but unconcerned, the scientific community has been preoccupied with the issue for at least 3 decades. And I'll go very briefly through this, but this idea that impacts constitute a contemporary hazard did not emerge until the end of the 20th century, so we're not looking at a very long history. But, and it was, as Chapman and Morrison described, even deemed a curiosity before this. But again, these catalysts, you know, the 1980 hypothesis, 1994 Shoemaker-Levy, planetary research, it motivated a more urgent appeal to look at this issue. So in 1981, NASA sponsored the Space Watch Workshop. In the 90s, we have the Space Guard Survey, which was the first comprehensive survey of asteroids over larger than 1 kilometer in diameter. And that kind of snowballed, and you know, the government, the US government in particular, has taken consistent steps to understand the issue more. And there's about $4 million in funding that go to this issue annually. Now, as a result of all of this, scientific understanding of the issue has advanced greatly. So much, in fact, that, as Morrison says, astronomers have already assured us that we are not due for an extinction-level impact from an asteroid within the next century. Barring an unlikely strike by a large comet, we are not about to go the way of the dinosaurs, so you can breathe easy. But that is in sharp contrast with the dominant narrative. You know, were you to watch the movies only by themselves, you would think that, you know, this is likely going to happen. And so, you know, as Morrison says, asteroids do not, except in Hollywood, change orbits capriciously. And that's because this narrative that we've just talked a little bit about ignores this element of predictability. You know, in science, we understand that chances are we understand enough of the orbits of the larger asteroids that we don't need to be concerned about those. In fact, we are now concerned about the sub-kilometer items, not the larger ones. But that element of predictability and that nuance of how different sizes of items could have different consequences completely lost in film, and particularly in film, but in general in fiction. Another element that's lost is this tied to the idea that we've put aside the major threat, and there's no sense of panic. If you read, for example, the NRC report, it says, and I quote, and it's right there, "The time required to mitigate optimally is in a range of years to decades, but this long period may require acting before it is known with certainty that an NEO will impact Earth." And so the arguments are for funding the sub-kilometer survey called for in 2005 and for exploring new technologies to identify smaller objects, and they are rooted in the desire to continue to dispel the threat and give us decades or centuries to get ready for an eventuality. But as you can see, it's a very different scenario from what is the main focal point of the dominant narrative. So this mismatch exists between public and scientific perception of the issue. And it helps explain why, despite the concerted efforts of prominent scientists to foster public concern and understanding of the issue, the public is not an active player in lobbying for what could be construed as the biggest threat the world could ever face. And there are many, many reasons to help explain this, which I won't go into today. But I think that the link to education is interesting, and this is what I want to leave you with. Because many of the authors say that, well, if we want the public on our side, we have to design a very aggressive educational campaign where they can understand the issue, and chances are that they are just not as aware of impacts and impact threats as we are. But I would argue that that situation is no longer true. You know, if you did not watch that great science documentary on asteroids, you probably sat through Armageddon and Deep Impact and Seeking a Friend for the End of the World. So, you know, culturally, we are aware of the threat. So I think the idea that the public just doesn't know about it no longer applies. I think there are other reasons that help explain why the public is not as concerned. And so I think that's one of the assumptions that needs to be questioned. The other one is this idea that improved education would lead to greater policy relevance, and that Hollywood and these films and these stories have a role to play in advancing that education. Hartwell says scientists owe a great debt of gratitude to the Hollywood blockbuster, and that's something that I would question. I think that what we may have seen is that these depictions only demonstrate the perpetuation of a specific view of the asteroid threat that is removed from a current scientific understanding of the issue, and therefore its real risk. And so I would leave you with just thinking that more research on public attitudes would probably be very helpful, and also considering the lessons from fields such as risk assessment to understand and to inform educational efforts that are aimed at having a real public policy impact. So with that, I thank you very much for your attention, and I look forward to your questions.
I realized that I forgot to read the bio, but I want to make sure that
It's
you
not
know.
long.
No, it's not long, so I'm going to read it right now so that you all know who Laura is. She is the Earth Observations Associate at the Institute for Global Environmental Strategies, and she's also a correspondent for SpacePolicyOnline.com and a recent graduate, like almost everyone in the room, it seems, of George Washington University's Space Policy Institute. Questions? Torrance?
Just a comment. It is a very interesting study. I appreciated it. I used to talk about the public perception problem with Gene Shoemaker quite a bit. And one take on this, obviously, is that humans have a hard time relating to threats that happen very infrequently on the timescale of the human lifetime. That's something that everybody that deals with this is. And it's interesting, just as a comment, to consider a thought experiment that in 1906, the San Andreas decided to break down in Coalinga instead of San Francisco, and the object that hit Tunguska was on a slightly different trajectory and took out downtown Moscow. We might have a different public perception.
Yes, I agree. And that's something that you find a lot in the research, your first comment about how, and you see it, there's a big spike in interest after a real event, after an impact, after the discussion on the media that an asteroid may hit the planet, and then it wanes. And I wouldn't necessarily think that that's a bad thing, because that's in our nature. I mean, the public responds that way, but policymakers respond that way. And I think scientists respond that way too, because, we can't be concerned about every single threat all the time. And so it's just one more challenge we have to deal with.
Marcia Freeman with the EIR magazine. It doesn't help me sleep too much better at night to know that scientists think that it'll be 100 years before there's a big impact. I think we need to know a lot more than we know. And there's a very interesting proposal. I was wondering if you knew about it or had any thoughts about it, that the Russians have made over the last year. It's part of the larger proposal was actually by General Permanov, who had been the head of the Russian space program, which is for a whole global coordination between global threats to Earth. It certainly includes something coming in here from somewhere else, but even the kinds of things that have large-scale impacts in terms of tsunamis, extreme weather events, which can affect a lot of countries, etc. And then a sort of more confined proposal for what's been called a strategic defense of Earth. Now, there are a lot of individual programs through the United Nations. You mentioned the U.S. programs, but really to bring this together in more of a global effort and to give it, to take away a little bit of the giggle factor, as you mentioned, and to say this is a scientific project that concerns us all globally, and the world's scientists are working on it.
That's a great point. I am aware of it, and I think that, again, that shows a whole very interesting discussion that is missing from the dominant narrative. I think you would make a great film talking about how the different countries and the proposals that they have and whether they'll be successful or not. Another point is that, and that's kind of one of the comments that I meant to kind of suggest in my very fast presentation, is that we understand that even sub-kilometer impacts would have damage, particularly depending on where they fall. If they fell in certain locations, in big cities, they would have a legitimate and an impact of a lot of concern. And so it's interesting that is missing from the popular discussion, because I think it is something that the public would be interested in.
Hey, Laura. So one of the slides had a dollar figure of about $4 million for tracking Earth or near-Earth asteroids, which I noticed probably about 2% of the budget of the movie Armageddon. What I noticed, you also had another slide that showed statistics talking about the public perception and saying that large percentages view this as a very low concern.
Mm-hmm.
Do you think that the public opinion drives the policy on that drives the low amount of funding? Do you think that perhaps the low amount of funding is the reason that the public is less concerned, or do you think that the two are detached?
No, I don't think the public concern drives it. I think in this case, the public and the policymakers are in the same side of the table. And so, like you said before, their interest is spiked by real events, and they do put more funding in it. But then, when it's not, well, other priorities take precedence. And so, I don't have any solutions to how you solve that. I think what the NRC is doing and what some in the community are doing are saying, sub-kilometer impacts, we need to survey those, we need to fund what Congress asked for in 2005 to survey those objects is good. But I think that bearing that very present and clear threat, there's not going to be that much attention given to it.
We'll have time for questions later, so if Lindley and you can save your questions for the panel, we'll certainly have time for that. But we do want to make sure we get all our presentations in. I just have a question. I want to take not for you, but you can answer it too. A survey. How many of you have ever seen a shooting star? All right, so you have seen an asteroid impact the Earth. You already have. So the statistics about 62% of the people don't think it's going to happen, but it happens all the time, every night. It's just a question of whether it's a really big one or not, all right? I know, and that's the point. She says people think of them as shooting stars. They don't understand what an asteroid impact really is because they have a Hollywood impression, and they don't realize that asteroid and comet impacts happen every single day. And it's just a question of degree. All right, so that's something that we need to communicate a little bit better, I think, that we aren't just talking about a one-off dinosaur killer. The Tunguska event I like to show superposed on Washington, D.C., because it encompasses, the tree fall pattern in Tunguska encompasses all of Metro Washington, D.C. So it's just something to keep in mind. Good to show your Congress people. All right, our last